Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most unsettling yet fascinating ideas in science: chaos theory. A place where the flap of a butterfly's wings in Brazil might ripple across the world and touch the skies of Texas, where order and randomness intertwine in ways that make life, nature, and the universe endlessly intriguing. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Take a deep breath. Let your shoulders relax. Let the quiet hum of the evening guide you as we step softly into a world where the tiniest actions can have the most extraordinary consequences. Imagine a world where every small choice, every flicker of movement, every gentle nudge in the course of events could subtly shape the outcome of something far larger than itself. You might picture a butterfly flapping its delicate wings in Brazil, an almost invisible motion, and yet somewhere far away, in Texas, a storm gathers, spinning and twisting as if the universe itself were listening to that faint whisper of air. This may sound like a story, even a playful exaggeration, but it captures the essence of one of the most fundamental insights of chaos theory: the profound sensitivity of our world to its tiniest beginnings. To understand this, it helps to think of the universe as operating in two fundamental ways. The first is what we might call the probabilistic mode. In this mode, chance, randomness, and uncertainty are the threads that guide outcomes. Here, a small, seemingly inconsequential event can cascade into consequences that appear astonishing, even miraculous. A conversation overheard, a single step taken differently, a leaf falling into a stream. These tiny shifts can subtly redirect currents, choices, and possibilities, creating effects that might seem entirely disconnected yet are intimately tied to that original spark. Life, in this mode, is a tapestry of delicate chance. On the other hand, there is the deterministic mode. Here, rules govern everything. Every cause leads to an effect. Every input has a defined outcome. And in principle, if we knew every detail about the starting point perfectly, we could predict the future with certainty. The world in this mode moves like a clockwork mechanism, precise and reliable, where the smallest detail is accounted for and each step follows logically from the last. Imagine tracing the path of a pendulum in a silent, sunlit room, every swing predictable, every motion following an elegant rule. This is the rhythm of order, the steady heartbeat of what can be calculated and known. The wonder and the mystery of the universe is that these two modes coexist. How can randomness and strict order dance together in a single system? How can the flutter of a butterfly coexist with the predictable swing of a clock? These questions, which might once have seemed beyond the reach of science, are central to the study of chaos theory. Chaos theory gives us a window into this strange, delicate balance. It reveals how systems governed by clear deterministic rules can still behave in ways that appear wildly unpredictable, if even the tiniest detail of the initial state is slightly different. It shows that unpredictability is not always a sign of randomness, but often the result of intricate sensitivity, a hidden responsiveness that we may never fully capture but can gently observe. Consider a simple illustration. Imagine a blank sheet of paper and 3 points forming a triangle. You start at a fourth point somewhere inside this triangle and follow a simple rule. Move halfway toward one of the 3 vertices chosen at random and mark a dot. Repeat this over and over. If you watch, at first the dot seems scattered and random. But as you continue, a beautiful repeating pattern emerges, the Sierpinski triangle. From what seemed chaotic comes symmetry. From apparent randomness arises a hidden order. This is the kind of quiet miracle chaos theory reveals. Even in systems that appear disorderly, there is structure waiting to be noticed. Or imagine a number that you repeatedly multiply by 10 and then remove the leading digit. Each step seems perfectly deterministic. There is no randomness, only the rule you follow. Yet after enough repetitions, the outcome becomes unpredictable. Small differences at the start or even slight rounding errors in a computer eventually grow into enormous divergences. The world behaves as if it has a mind of its own, yet it is following nothing more than simple, predictable instructions. Chaos theory tells us that this is not a peculiarity of numbers or paper dots. It is the rhythm underlying life, ecosystems, weather patterns, and even the beating of your heart. Tiny differences, subtle choices, small shifts can ripple outward, creating effects that touch distant corners of a system in ways we cannot foresee. And yet, amidst this unpredictability, hidden patterns, structures, and emergent beauty can always be found if we look closely enough. So as you settle deeper into your chair or bed, notice the quiet connections in your own life, the choices, the subtle events, the tiny movements that ripple outward. In the world of chaos theory, nothing is too small to matter, and nothing is so random that it lacks meaning. The universe, it seems, is always listening, always responding, and always quietly weaving a tapestry of intricate, invisible patterns. Take a soft breath and let this idea sink in. We live in a world that is at once orderly and unpredictable, rule-bound and full of surprises, delicate and astonishing. And with that gentle awareness, we're ready to explore the intricate dance of chaos, the hidden threads that connect everything from the flap of a butterfly's wings to the far reaches of the cosmos. Imagine standing on a hillside just before a storm. The air feels heavy, still yet somehow alive. You can sense that something enormous is brewing in the sky above. Clouds thickening, winds shifting ever so slightly, tiny tremors of energy threading through the air. You might think the storm's arrival is simply weather doing what weather does, but beneath that familiar drama lies something far more mysterious. What if that storm was not inevitable? What if it was just one of many possible outcomes, born from invisible, almost imperceptible beginnings? That question haunted a meteorologist named Edward Lorenz in the early 1960s. He wasn't setting out to change our understanding of the universe. He was simply trying to predict the weather more accurately. Lorenz built one of the earliest computer models of atmospheric motion, a set of equations describing air temperature, pressure, and wind. Nothing unusual, nothing magical. He would feed in the data, watch the simulated storm systems evolve, and compare his results with actual weather. But one day, in the middle of a routine test, something strange happened. Lorenz decided to rerun a simulation, but instead of starting it completely from scratch, he typed in numbers from an earlier printout. These numbers represented the conditions of the atmosphere at a given moment: temperature, pressure, humidity. The only difference was that the printout rounded each value slightly. Instead of something like 12,927, the computer printout showed a difference smaller than a puff of air. When Lorenz ran the program again, the results began the same but soon drifted apart. At first, the simulated storm patterns looked nearly identical. Then, gradually they diverged, slightly at first, then wildly. The new run produced weather patterns utterly unlike the original. Lorenz was stunned. A difference so small it could barely be written down had changed the entire outcome. He called it sensitive dependence on initial conditions, though the world remembers it by a gentler name, the butterfly effect. It's easy to misinterpret this idea as saying that one butterfly really causes a tornado. But Lorenz never meant it so literally. What he discovered was something deeper, that in complex systems, small differences grow exponentially over time. Each flap of a wing, each tiny change, each rounding error compounds, amplifies, and eventually becomes impossible to trace. In a perfectly deterministic world, the kind of world we once imagined, made of clockwork certainty, such a result shouldn't happen. If you know where every atom is and how it moves, you should be able to predict everything forever. That was the dream of classical science, that reality was a machine and knowledge was the key. Lorenz showed that even in a world run by perfect laws, long-term prediction could fail, not because the world was random, but because it was exquisitely sensitive. A single missing whisper of data could set reality spiraling down a new, unrecognizable path. To understand this without equations, picture yourself stirring milk into coffee. At first, you can see clear swirls of white mixing with dark brown. Each circle of the spoon creates graceful, visible lines, but keep stirring, and the pattern dissolves into something unpredictable. You can never unstir the coffee, never get back the same beautiful spirals, even if you stir again in exactly the same way. Each motion interacts with billions of molecules in slightly different ways, and the result becomes impossible to reproduce. The process follows rules, but the outcome dances beyond your reach. That's the heart of chaos theory. Beneath apparent disorder, there are rules. Beneath randomness, there is structure. But those rules do not guarantee predictability. The more complex a system becomes, the weather, the human brain, the beating of your heart, the movement of economies, the more those small beginnings matter. Lorenz's discovery became a quiet revolution in science. Suddenly, predictability itself had limits. No matter how powerful the computer or how detailed the data, there was a horizon beyond which certainty vanished. The world was still deterministic, still governed by laws, but those laws could produce beauty and unpredictability side by side. To visualize this, scientists sometimes use what they call phase space, but let's imagine it in a gentler way. Picture a meadow filled with invisible pathways, each representing how a system might evolve. Drop a marble somewhere on this meadow, and it rolls along a particular path depending on where it starts. Move it just a hair's breadth to the left, and its entire journey changes. That's how weather behaves. That's how life behaves. Every starting point unfolds differently, even when the rules are the same. Chaos doesn't mean pure disorder. It means an intricate dance of order and unpredictability, a balance so delicate that the slightest tremor can shift the rhythm. Nature seems chaotic only because we can't feel the infinite precision of every beginning. And this pattern doesn't belong only to storms or equations. You can find it in your own life. A single choice, a missed train, a smile returned at the right moment. Each tiny event ripples outward through time in ways that no one could predict, shaping days, years, and even generations. If you trace back through your life, you might see how the smallest decisions, the ones that seemed insignificant, opened doors or closed them. That is the butterfly effect written into human experience. In many ways, chaos theory is a humbling idea. It reminds us that even when we believe we have control, there are layers of subtle influence at work, patterns too deep, connections too delicate to measure. Yet it also offers comfort, because if small actions can unleash vast consequences, then meaning exists everywhere. Every gesture, every word, every heartbeat matters. The world is not indifferent. It is exquisitely alive to every touch. So as the imagined storm finally breaks and the rain begins to fall, you might listen to the drops tapping softly on the window and think of Lorenz's discovery, of how each raindrop's path, though following the same laws of motion, is still utterly unique. Beneath the surface of every storm, every thought, every moment, there lies an invisible network of connections linking all things. And perhaps that's the quiet, secret chaos theory wants us to see, that the universe is not just unpredictable, it's sensitive, responsive, and alive. Every whisper of air, every flicker of thought, every tiny cause becomes part of the grand conversation of existence, echoing softly through space and time. Let's try something together, not with numbers or formulas, but with imagination. Picture a blank sheet of paper in front of you. In the soft light of a lamp, draw 3 dots, each one forming a triangle's corner. Nothing complicated, just 3 simple marks. Now pick a spot somewhere inside that triangle, anywhere you like, and call it your starting point. Now imagine rolling a die. If you roll a 1 or a 2, move halfway toward the top corner. If you roll a 3 or 4, move halfway toward the bottom left. And if you roll a 5 or 6, move halfway toward the bottom right. Mark your new position with a dot, then roll again, and again. Each time, move halfway toward the corner your roll tells you to. At first, your page looks random, dots scattered like dust across white paper. But after a few hundred rolls, something remarkable begins to happen. Slowly, quietly, a delicate shape emerges from the noise. Triangles within triangles, forming a lace-like pattern that repeats endlessly at smaller and smaller scales. You've just created what mathematicians call the Sierpinski triangle. But there's no need to say that name aloud. Just imagine it. A snowflake made of emptiness, a window into the secret geometry of chance. What's extraordinary about this little experiment, often called the chaos game, is that it turns randomness into structure. The rules you followed are simple. The die rolls are random, yet from this randomness emerges a design that's precise, symmetrical, and infinitely deep. It's as though the universe itself is whispering through your pencil, showing that what looks like chaos can be the seed of order. This is the essence of fractal geometry, patterns that repeat themselves at different scales, revealing self-similarity across infinity. Fern leaves, lightning bolts, mountain ridges, and even the branching of your lungs all share this same quiet rhythm of repetition. Nature doesn't draw straight lines. It draws patterns that echo themselves endlessly, big and small, like verses of the same cosmic poem. Think about the branching of a tree. Each twig resembles the limb it grows from, and that limb resembles the trunk. The whole tree is contained, in miniature, within every part of itself. Or consider a coastline seen from a plane. Rugged, irregular, repeating shapes within shapes. Zoom in with a camera, and the pattern doesn't smooth out. It continues. New bays, new curves, smaller and smaller echoes of the same form. The chaos game reveals that even simple rule-based systems can give rise to complexity that feels alive. You don't need complex equations to see it. You just need to look at how repetition, feedback, and tiny choices build on one another. Each roll of the die adds a note to a growing melody, unpredictable in the short term, but harmonious in the long run. It's a bit like life, isn't it? Each of us begins with a blank page, making small decisions that seem random at first. One day you choose a path, another day a different one. Each step feels disconnected, yet when you look back years later, a pattern begins to appear. Your story, your experiences, your relationships, they form a shape that could never have been seen from the start, but in hindsight feels inevitable. The randomness of your life has been quietly drawing its own kind of triangle. The idea that simple rules can generate infinite complexity is both humbling and uplifting. Benoit Mandelbrot, the mathematician who coined the term fractal, once said that clouds are not spheres, mountains are not cones, and coastlines are not circles. The world, he noticed, defies the neat shapes of human geometry. It prefers curves, folds, and intricacies, beauty born from irregularity. The chaos game is our simplest window into that truth. You can imagine it as the universe playing with dice. Each outcome, each tiny shift, creates something unpredictable, yet never meaningless. From the roll of a die, a fern leaf is born. From the flutter of air, a storm takes shape. From the flicker of neurons in your brain, a thought forms, a dream begins. What's even more beautiful is that these patterns never repeat exactly. In a random process, you might expect repetition, a loop that eventually comes back to where it started. But chaotic systems are different. They wander forever through their own space of possibilities, never tracing the same path twice. Each moment is unique, unrepeatable, yet still follows the same hidden rhythm. If you were to plot these points, every dot would seem lost at first, scattered like stars across the night. But as you wait, patterns emerge, not through control, but through the quiet persistence of the rules themselves. It's as though the universe hides its order in time, revealing it only to those patient enough to keep looking. In a sense, the chaos game is a miniature version of how reality unfolds. Tiny interactions following consistent rules create the endlessly complex world we live in. The dance of atoms, the swirling of galaxies, the rise and fall of civilizations, all might be different verses of the same universal pattern. And it reminds us of something comforting. The world doesn't need perfect order to be beautiful. It doesn't need certainty to make sense. The most stunning patterns emerge not from control, but from the balance between chance and structure, from the way small actions echo through space and time. So, if you ever feel that your life is scattered, like dots on a page that lead nowhere, remember this: every small step, every roll of the dice, every choice you make contributes to a pattern that may not yet be visible. The universe builds meaning the same way the chaos game draws its triangle, patiently, quietly, one point at a time. Look closely enough, and you might just see the pattern forming. Not random at all, but a reflection of something much deeper, hidden in plain sight. Now that you've seen how order can quietly emerge from randomness, let's turn the idea upside down. What if we take something perfectly orderly, something that follows rules with absolute precision, and watch it slowly slip into unpredictability? Imagine you have a simple number, any number between 0 and 1. Let's say you pick one that feels pleasant, something like 0.5. Nothing mysterious about that. Now, imagine that you follow a rule. Multiply it by 10, then take away the part before the decimal point. For instance, if you multiply 0.5 by 10, you get 5. You remove the 5, and you're left again with 0.0. Then you do it again. Multiply by 10, remove what's before the decimal and keep going. Each step follows the same rule. No guessing, no dice, no chance. You could write the instructions on a napkin. Multiply, cut, repeat. It's completely deterministic, meaning the next result always depends exactly on the one before it. And yet, after enough repetitions, something strange begins to happen. If you start with 0.5, the pattern unfolds one way. If you start with 0.50001, just a tiny difference, the kind of difference so small it would fit between atoms, you'll end up with a completely different sequence after a few steps. Two paths that begin side by side suddenly wander apart, never to meet again. It's like two leaves floating down a stream. At first, they drift together, close enough to touch, but as the water moves, around rocks and curves, the current gently separates them. One leaf catches a swirl of motion, another rides a deeper wave, and soon they are far apart, carried toward different horizons. The rule governing the flow of the water hasn't changed. It's the same river. But the tiniest difference in where each leaf began has changed their stories forever. That's deterministic chaos in its purest form. Systems that obey strict rules, yet whose long-term behaviour cannot be predicted because they're so sensitive to their starting point. This sensitivity isn't limited to abstract numbers or imaginary leaves. It exists in every natural process. When a pendulum swings from a single string, it moves predictably, back and forth, graceful, soothing. But attach one pendulum to the bottom of another, and suddenly the motion becomes wild. A tiny push at the start will send it into a completely different dance. The system hasn't become random. It still follows the same laws of motion, but it's now so sensitive that even the faintest breath can change its entire path. Scientists sometimes describe these systems as having a phase space, which you can imagine as a map of all the possible ways something might move or change. On that map, a simple pendulum traces a neat oval, looping back to where it started again and again. A chaotic pendulum, though, draws something very different. An intricate, tangled pattern that never crosses itself, never repeats, and never truly ends. Each line is both familiar and new, like music that never quite resolves its melody. In mathematics, this pattern is called a strange attractor, but there's nothing strange about it once you see it through your imagination. Think of it as the invisible shape of motion itself, the path that chaos carves into possibility. A strange attractor is what keeps the chaos from dissolving into nonsense. It's the hidden boundary inside which all those unpredictable movements swirl. Like a murmuration of starlings, thousands of birds twisting in the air, never colliding, each responding to tiny signals from its neighbours. Their motion seems random, but is held together by unseen coherence. What's so beautiful about this is that it shows how chaos and order aren't opposites at all. They coexist. The storm that seems wild is still guided by physics. The swirling pendulum still obeys gravity. Even the unpredictable pattern of your heartbeat follows laws that keep it alive. To understand this without losing the softness of it, imagine playing a piano. Each note you strike is deliberate, but the way the sound fills the room, bouncing off walls, blending with echoes, merging with silence, that's where the unpredictability lies. The notes are rules, the resonance is chaos. Together they make the music alive. The number game we started with follows the same principle. The rule, multiply and cut, is the sheet music. But the way small rounding, errors grow like echoes that refuse to fade, is what turns it into a symphony of unpredictability. You could start with 1,000 different numbers, and after a while, none of them would sound the same. Even the most powerful computers can't keep up forever. Every machine stores numbers with a limit, a finite number of digits. And just as the smallest rounding error sent Edward Lorenz's weather models spinning into new futures, those digital limits mean that computers too can never predict perfectly. Beyond a certain point, the world slips through the cracks of precision. This isn't a failure of mathematics, it's a revelation about reality. The deeper we look, the more we see that the world's apparent unpredictability isn't due to randomness, but to its impossible richness. Each detail, no matter how small, matters. Each beginning contains countless possible endings, and this has a quiet poetry to it. Because if everything were predictable, life would be mechanical. A movie already filmed, a song already written. But instead, we live in a universe that surprises itself. A cosmos that can't quite predict its next verse. So, when you think about chaos, think of it not as disorder, but as depth. A reminder that every moment is unique because it arises from an infinity of subtle beginnings. The world doesn't need to be random to be full of wonder. It just needs to be alive, trembling slightly at the edges of certainty, always ready to unfold into something new. As you rest now, perhaps picture those two leaves again, drifting apart downstream, each following the same current, yet each carried to a different sea. That's deterministic chaos, a world of rules and patterns that somehow never repeats itself, a reminder that every breath, every heartbeat, every small beginning carries the quiet potential to change everything. Picture yourself watching a flock of birds at dusk, hundreds of them, moving together in a living cloud. The entire shape seems to shift and twist in the wind, one moment like smoke, the next like a wave, and yet, somehow, they never collide. Each bird responds to the smallest changes in its neighbours, adjusting direction and speed in perfect balance. To the eye, it looks like chaos. To the heart, it feels like music. But hidden within that motion is something extraordinary, a pattern that never quite repeats, yet always remains beautifully bound together. That image captures what scientists call an attractor. In soft terms, an attractor is a path or a destination toward which a system tends to move. Even in the midst of apparent confusion, things are drawn towards certain shapes, patterns, or states. You could think of it like a valley. Drop a marble anywhere on the slope, and it will eventually roll toward the lowest point. That's a simple attractor, predictable and calm. But some systems, especially those that live on the edge of chaos, behave differently. They never settle. They keep flowing and changing, yet their movement still hovers within invisible boundaries. If you could somehow draw every possible position of such a system on a piece of paper, it would never trace the same path twice, and yet it would never stray too far away either. The result would be a complex, tangled shape, intricate, mesmerizing, and infinitely detailed. This hidden structure is what scientists call a strange attractor. The phrase might sound mysterious, but it simply means that the system, while unpredictable, is still confined to an underlying order. Chaos in this sense isn't complete disorder. It's an endless dance between freedom and form. You can imagine it more gently. Think of a moth circling a porch light. It flutters in unpredictable loops and spirals, sometimes close, sometimes far, but always drawn back by the faint glow. The moth's flight never follows the same path twice, yet its journey is framed by an invisible pull, a quiet guidance in the darkness. That's what a strange attractor is, the silent shape of motion, the outline of where things can go, even when the route is never the same. One of the most famous of these patterns was discovered fittingly by Edward Lorenz, the same meteorologist who found that a butterfly's wings could change the weather. When Lorenz mapped the equations that described air currents in his model, he expected to see random scatter. Instead, he saw something breathtaking. A swirling figure made of two spirals side by side like the wings of an invisible butterfly. Points that represented the weather's state darted and curved around these twin loops, never repeating, never crossing, yet always remaining within the same graceful shape. That delicate figure became known as the Lorenz attractor. It's a portrait of the atmosphere's hidden order, unpredictable in the short term, yet bounded in the long term. If you were to watch it unfold, it would seem alive, fluttering endlessly without ever landing. To describe this in words rather than symbols, imagine tracing a path through time where each step depends on what came before. The next moment in the system's life depends on its current motion, much like your next breath depends on the rhythm of the one before. Over time, these moments spiral outward and inward, folding over themselves, weaving a pattern that looks both deliberate and improvised. The system never pauses, yet it never dissolves. It finds stability in side movement, a form within flow. That's what makes strange attractors so mesmerizing. They suggest that chaos isn't the absence of order, but the presence of a deeper, subtler kind of order, one that breathes and moves instead of standing still. You can find echoes of this everywhere in the natural world. In the pulsing of your heart, there's rhythm and irregularity, a beat that is never perfectly uniform, yet remains beautifully steady overall. In the tides of the ocean, the waves never crash in the same place twice, but the coastline still holds them close. Even the fluctuations of your breath as you drift towards sleep, each inhale a little longer or shorter than the last, trace their own quiet attractor, a stability hidden inside change. There's something profoundly comforting about this idea. It tells us that even in the moments when life feels unpredictable, when events seem to twist and turn beyond control, we are still part of a larger pattern. Like the moth drawn to the light, or the birds finding coherence in their flight, our paths may never repeat, but they remain bound within the gentle pull of meaning. If you could see your own life drawn across time, every thought, every movement, every connection you've ever made, it might look just as complex as a Lorentz attractor. You would see arcs looping back, crossing near old memories, spiraling out into new experiences, yet always remaining within the same invisible boundaries of your nature, your hopes, your heart. You may never trace the same path twice, but you never leave yourself entirely either. You wander, but you belong. And perhaps this is one of the quiet lessons of chaos, that our world, our lives, and even our emotions are not linear or tidy. They twist, flow, and loop in ways that can feel confusing. But beneath that confusion lies a kind of grace. Stability doesn't mean stillness, it means learning to move within your own changing shape. So the next time you feel lost in uncertainty, imagine those twin spirals of Lorentz's invisible butterfly, a symbol of motion that never settles, yet never falls apart. Its flight reminds us that even when everything seems to shift beyond prediction, there is still a shape holding it all together, delicate and enduring. You might think of the universe itself as following an endless strange attractor, galaxies spinning, stars being born and dying, cosmic dust gathering, collapsing, reforming, all part of a pattern too vast to see, yet bound by the laws of balance and energy. The cosmos, like a flock at dusk, moves in swirls of unpredictability, but never truly loses its harmony. And as you imagine those shapes in motion, the spirals of air, the murmuring birds, the fluttering butterfly, you might feel a sense of quiet stability too. Even in chaos there is rhythm. Even in the unknown there is belonging. The pattern never repeats, but the beauty always remains. Take a slow walk in your imagination through a forest just after rain. The air smells of earth and moss. The sunlight filters through wet leaves, and as you look closer, you notice something quietly astonishing. Patterns repeating everywhere. The smallest fern frond mirrors the shape of the whole plant. A branch of a tree forks just like the trunk that gave birth to it. Even the veins of a leaf spread in miniature rivers that echo the branching of the great river beyond the woods. You're surrounded by repetition, shapes within shapes, worlds within worlds. This is the living language of fractals, patterns that repeat at different scales, endlessly, beautifully, and without ever truly being the same twice. In simple terms, a fractal is a pattern that contains smaller copies of itself. But that definition, though true, doesn't quite capture its poetry. To see fractals is to glimpse the handwriting of nature, its rhythm, its breath, its quiet insistence on harmony amid complexity. Fractals can be drawn with equations, but you don't need mathematics to see them. You only need to look carefully at the world. The jagged peaks of mountains, the curling edges of waves, the delicate frost on a window, all carry the same repeating rhythm. Zoom in, and the pattern continues. Zoom out, and it's still there. It's as if nature prefers to whisper the same melody in different octaves. The French mathematician Benoit Mandelbrot, who first gave these patterns their name, once said that the shapes of clouds and mountains cannot be captured by the geometry of straight lines. The world, he said, is rough, and that roughness is its beauty. If we could somehow smooth away the irregularities of the earth, we would erase what makes it real. Mandelbrot's insight was that this roughness is not random. It follows a deep logic. It's chaos with memory. Every fold and curve is an echo of the one before. To feel what this means, imagine the edge of a coastline seen from an airplane. It looks like a simple curve, but as you fly lower, you see coves and inlets. Closer still, you see smaller ripples, rocks and indentations, and then at ground level, grains of sand and the lines left by retreating waves. Each level reveals new detail, but the shape, the jagged, irregular contour, is always the same kind of shape. It repeats endlessly, though never perfectly. That is the essence of fractals. Repetition without monotony. Order within imperfection. Fractals are not limited to landscapes. They live inside you too. The network of blood vessels in your body branches in the same pattern as the trees that produce your oxygen. The tiny airways in your lungs mirror the branching of river deltas. The neurons in your brain spread like roots, intertwining and splitting, carrying thoughts the way rivers carry rain to the sea. You are, in a sense, made of the same geometry that forms mountains and storms. When you breathe, every molecule of air follows the pathways of your lungs, pathways that fold and refold like the patterns of a fern leaf. This design isn't just beautiful, it's efficient. Fractals allow life to fill space elegantly, ensuring that every part of your body receives what it needs. Nature doesn't waste lines. It repeats them, refines them, reuses them, in a pattern so old and perfect that even galaxies spiral in its rhythm. If you've ever watched lightning stretch across the sky, you've seen a fractal unfold in real time. Each bolt branches into smaller and smaller paths, splitting at angles that seem random but actually follow physical laws. Electricity always seeking the shortest way to ground, just as water seeks the easiest path downhill. Fractals are the fingerprints of flow. Energy, matter, and life all follow them as they move from one state to another. Even the humble snowflake, delicate and fleeting, holds a fractal soul. Under a microscope, its sixfold symmetry reveals an astonishing truth. Each branch mirrors the others, each layer repeating at smaller scales. The laws of temperature and humidity shape its growth, but no two snowflakes ever form exactly alike. In that sense, fractals are the universe's favourite compromise, structured enough to be recognisable, flexible enough to be endlessly unique. In the quiet mathematics of chaos, fractals are the soft revelation that complexity can arise from simplicity. A single rule, repeated over and over, can create infinite variation. Think of waves washing against the shore. Each wave follows the same law of motion, yet no two ever break in the same way. The world loves repetition, but it never repeats itself exactly. You can see fractals even in human creations that echo nature. The branching streets of an old city, the veins of a leaf carved into stained glass, the spirals of a cathedral staircase, all born of our instinct to imitate the natural rhythm that built us. We're drawn to patterns because we are patterns, and there's something deeply calming about recognizing this. When you realize that the same structures appear in your lungs, in trees, in rivers, and in galaxies, the boundaries between you and the universe begin to soften. You're not separate from the world, you're part of its repeating song. Mandelbrot once described fractals as the geometry of reality, a way of capturing the infinite within the finite. But if you step back from the science, it's also a way of seeing beauty in imperfection. The edges of things, the rough, the uneven, the complex, are not mistakes. They are evidence of the world's creative energy, endlessly expressing itself through repetition and surprise. So the next time you find yourself beneath a tree, look up at the branches. Notice how each one divides and stretches, mirroring its parent, each smaller branch a quiet echo of the whole. The pattern is infinite, but it feels intimate. The same design that governs the stars also guides the veins in a single leaf. And if you listen closely, you might sense what chaos theory has been whispering all along, that even in what seems wild and unpredictable, there is order hiding in plain sight. The world repeats its shapes not out of habit, but out of love for its own rhythm. Every curve, every fold, every repetition is a gentle reminder that life is a single pattern, infinite, self-reflecting, and forever unfolding. If you've ever stood at the edge of the ocean and looked out at the endless horizon, you may have felt a strange sensation that the vastness outside you somehow mirrors the vastness within. The rolling waves, the pulse of the tide, the way the sea seems to breathe. It's as if nature itself inhales and exhales just as you do. The ancient philosophers had a word for this reflection between the great and the small. They called it the harmony of the microcosm and the macrocosm, the little world inside us and the great world beyond, endlessly mirroring each other. In the age before telescopes and microscopes, thinkers like Plato and Pythagoras imagined the universe as a living organism. The stars were its eyes, the wind its breath, and human beings were tiny reflections of that same cosmic design. They sensed what modern science has since confirmed through fractals, feedback loops, and systems theory, that patterns repeat themselves at every scale, from the motion of galaxies to the flow of blood through our veins. When you look at a river delta from above, winding, branching, endlessly splitting, you see the same geometry that shapes the veins in a leaf or the arteries in your body. The great and the small are built from the same logic, like verses written in different sizes of the same poem. The flow of blood through your capillaries and the swirl of galaxies through the cosmos are both dances of energy-seeking balance, guided by the same simple laws of motion and feedback. In the quiet rhythm of your heart, there's an echo of the rhythm of tides. The electrical pulses that move between your brain cells mirror the bursts of light that travel between distant stars. Even the cells of your body, dividing, adapting, communicating, follow the same patterns of cooperation and competition that shape ecosystems and societies. If you could zoom out from Earth, past the swirl of clouds and the glittering atmosphere, you'd see something that looks uncannily familiar. The web of galaxies stretching through the universe forms filaments and clusters that resemble the network of neurons in the human brain. Both are systems built to connect, to exchange, to evolve through complexity. And though they differ in scale by unimaginable orders of magnitude, their shapes rhyme with each other as if the universe uses the same design language across all its creations. This mirroring across scales isn't just poetic, it's physical. In chaos and complexity, the same mathematical patterns govern how systems grow, adapt, and self-organize. Whether it's a hurricane forming in the sky, a coral reef expanding under the sea, or your mind generating a thought, each process unfolds through feedback and sensitivity. Small causes ripple outward, large systems fold inward, and somewhere in between, a kind of balance emerges, not static but alive. The poet William Blake once wrote, "To see a world in a grain of sand and heaven in a wild flower." Chaos theory helps us understand that this isn't just metaphor, it's reality. Every grain of sand carries the memory of the forces that shaped it, the waves, the winds, the pressure of the earth. The same physics that sculpts continents also guides the tiniest particles. When you hold a pebble, you're holding a story written by mountains and time. In science, we sometimes talk about scale invariance, the idea that some patterns look the same no matter how much you zoom in or out. You can imagine it as holding a mirror up to a mirror, reflections stretching into infinity. Nature doesn't distinguish between small and large in the way we do. To it, the laws are the same, the melodies simply repeat at different pitches. Even our emotions and behaviours often echo these patterns. A single human life, with its moments of calm and storm, mirrors the pulse of ecosystems and civilizations. The rise and fall of societies follow rhythms not so different from the growth and decay of forests, expansion, saturation, collapse, renewal. What we call history may be the universe expressing its own cycles through human stories. You can also see this reflection in time itself. The patterns of the past repeat in new forms, just as the shape of a fern repeats in each of its leaves. The butterfly effect works not only in physical systems, but also in history and memory. A single act of kindness or cruelty rippling outward across generations, shaping futures we will never see. And within this endless repetition, there's a kind of reassurance. If the same beauty that governs the stars also moves within you, then perhaps chaos is not something to fear, but something to belong to. You're not an observer standing apart from the universe. You're a participant in its unfolding, one cell in the body of something vast and alive. When you breathe, the air you take in contains atoms that have travelled through ancient forests, volcanoes and oceans, even through the lungs of creatures long gone. Those same atoms will someday become part of clouds, rivers and other lives. Matter moves through cycles, endlessly reused. What was once sunlight becomes leaf, then fruit, then you, and one day something else again. This is the great exchange between the microcosm and the macrocosm. Everything feeds into everything. Every spark that burns within you once shone in a star. Every breath you release may one day stir a distant storm. You're both the butterfly and the breeze it rides upon. Perhaps this is why so many people feel a quiet peace when looking at the night sky. It's not only the beauty of the stars, but the recognitions, deep and wordless, that their light is also your light. The same patterns of chaos and order that weave galaxies together also weave the rhythm of your heartbeat. The distance between the vast and the intimate is an illusion. So, when you look out at the world, the curve of a river, the spiral of a shell, the branching of your own hand, remember that you are seeing echoes of yourself everywhere. The world outside and the world within are reflections of the same mysterious design, endlessly folding into one another like the pages of a never-ending book. And in that realization, chaos no longer feels frightening. It feels familiar, like recognizing your own reflection shimmering back from the surface of a quiet pond. There's a peculiar peace in watching the sky before a storm. The air thickens, as if the world is taking a deep breath. Clouds gather like heavy thoughts, and for a brief moment everything holds still. Somewhere above, invisible currents of air twist and fold around each other, guided by laws as ancient as the earth itself. If you could see those invisible movements, every gust, every eddy, every flicker of rising heat, it would look like an intricate tapestry, woven by the wind and changing every second. And within that swirling fabric lies one of the most beautiful and haunting ideas ever discovered, that even the tiniest motion can change everything. This is the essence of the butterfly effect, the poetic heart of chaos theory. You've heard it before, perhaps as a metaphor. The flap of a butterfly's wings in Brazil might set off a tornado in Texas. It sounds like exaggeration, but what Edward Lorenz uncovered in the early 1960s wasn't a metaphor at all. It was a mathematical truth. Lorenz had built one of the earliest computer models of the atmosphere. His goal was simple: to understand and predict weather patterns using equations that described how temperature, pressure, and air currents interact. The model was small by today's standards, just 12 simple instructions, looping through calculations again and again. Yet when he ran the same simulation twice with slightly different starting numbers, the results diverged wildly. The difference he had introduced was almost laughable. The kind of difference that would come from rounding a number like 0.506127 to 0.506. It was as if he had whispered a single syllable differently, and the weather had written a new story. To visualize this without equations, imagine you're rolling a small marble down a mountain. At the top there's only one path, but a little farther down the terrain forks into 1,000 valleys. A shift smaller than the width of a hair at the start can send the marble down a completely different slope, leading to a different forest, a different stream, a different sea. The same applies to air molecules in a storm. Every molecule follows the same rules of physics, yet a difference so tiny it seems meaningless can, over time, create a storm that never would have existed otherwise. This is what Lorenz discovered, that even in systems governed by strict laws, long-term prediction may be impossible because of the sheer sensitivity to initial conditions. It's not that the weather is random, it's that it's too finely detailed for us to ever know every starting point exactly. Every butterfly, every leaf, every rooftop contributes a whisper to the air, and together they compose the ever-changing song of the sky. Chaos theory doesn't make the world more confusing, it makes it more intimate. It reminds us that everything is connected in ways too delicate to measure. A wave breaking on a distant shore may have started as the faintest breeze on another continent. A drought may trace its lineage back to a single shift in ocean temperature years before. You can see the butterfly effect in motion every time you check a weather forecast. For a day or two, predictions are fairly reliable. Tomorrow's rain, the weekend's sunshine. But stretch those forecasts out beyond a week, and certainty begins to crumble. It's not because meteorologists lack skill or data. It's because chaos magnifies the smallest uncertainties until the future becomes a fog of possibilities. The limits of prediction are written into the very fabric of the atmosphere. And yet, within that unpredictability, there's beauty. Weather is never truly repeated. Every cloud, every gust, every raindrop falls in its own pattern, shaped by countless interactions that will never happen the same way again. The air around you is alive with history. Every molecule once part of 1,000 storms, every gust a descendant of movements that began before you were born. If you could trace a single raindrop's journey, you might find that it once evaporated from the Pacific Ocean, rose into a storm above Japan, drifted across the Arctic, fell as snow in Canada, melted into a river, and returned again to the sea. It's a cycle without end, guided by the subtle mathematics of chaos. Even in the chaos of a thunderstorm, there are patterns hiding in the noise. The way lightning branches through the clouds follows the same fractal rhythm as roots spreading through soil. The swirling motion of a hurricane mirrors the spiral arms of galaxies. What we call disorder is simply complexity beyond our grasp, a language of motion so vast that no mind can hold it all at once. And perhaps that's why storms, despite their violence, can be strangely soothing to watch. There's something deeply human about seeing order and unpredictability intertwined, the world revealing both its precision and its freedom at once. The rain doesn't fall by chance, it falls according to laws. But the pattern it follows is too intricate to ever predict perfectly, too alive to ever repeat. If you listen closely to the sound of rain, you'll hear this truth in miniature. Each drop strikes differently, creating a rhythm that's familiar yet never identical. It's chaos in its gentlest form, deterministic and unpredictable all at once. In a way, we are all weather systems. Our thoughts, emotions and choices swirl and mix like air currents, influenced by everything around us. A word spoken in kindness or carelessness can ripple through another life like wind shaping a wave. Every action, however small, becomes part of a pattern too large to see, yet real in its effects. Lorenz's butterfly was never just about meteorology. It was about the nature of influence. How small beginnings can lead to immense outcomes. In a universe this sensitive, nothing is truly isolated. Every breath joins the wind, every thought adds to the currents of human experience. So when you think of chaos, don't imagine destruction. Imagine connection, the quiet truth that every motion, no matter how small, is felt somewhere, sometime, in some way. The butterfly's wings are not a symbol of disaster. They are a reminder of belonging. Next time you feel a breeze past your face, remember, that breath of air might carry the memory of a distant wing, a leaf, a ripple, the faintest gesture of the world reminding you that everything moves together. And perhaps, as you listen to the whisper of the wind, you'll hear the softest echo of your own place within it. Close your eyes for a moment and picture a forest at dawn. The air is cool, soft with mist, and alive with the faint hum of wings and rustling leaves. Somewhere, unseen, a wolf pads through the undergrowth. Far away, a deer lifts its head, ears twitching, sensing something it cannot name. The two are connected by invisible threads, not of chance, but of balance. In that delicate relationship lies one of nature's most elegant examples of chaos, the predator and the prey, endlessly shaping each other's fate. When scientists study such relationships, they see something both predictable and unpredictable, a pattern of rise and fall, of abundance and scarcity that repeats over time but never in quite the same way. When the deer population grows, food becomes plentiful for the wolves. The wolves thrive, their numbers rise, and soon they hunt more. As they do, the deer begin to dwindle. With fewer deer to feed on, the wolves too begin to decline. As the predator numbers drop, the deer population recovers once more, and the cycle begins again, looping forever like a natural pendulum, but never swinging exactly the same way twice. This kind of feedback loop is nature's version of a heartbeat. It beats with life, responding to changes in weather, food, disease, and time. Yet, it is also unpredictable. A sudden cold winter, a shift in the forest's food supply, or even a single pack's migration can alter the rhythm entirely. The forest, like the weather, lives in the realm of non-linear systems, where the whole is shaped by countless small parts interacting at once. To put it softly, ecosystems are conversations, not monologues. Every leaf that falls, every raindrop, every tiny creature adds its voice to the chorus. The forest breathes because its inhabitants breathe together, and in that breathing, chaos becomes harmony. If you were to watch this forest from above, you might see it as a single living being, trees spreading their roots like neurons, rivers flowing like veins, clouds gathering like thoughts. Yet beneath that unity, every part follows its own rules, adapting, reacting, and influencing all the others. A beetle chews through bark, changing how the tree grows. The tree's growth alters the light beneath it, which changes where flowers bloom. The flowers attract new insects, and so the cycle deepens, an endless ripple of cause and effect. This is the same principle that governs weather or galaxies, only now expressed through the language of life. Each organism plays its role, following simple instincts: eat, grow, rest, reproduce. Yet together they create a system so complex that no one could predict exactly how it will behave. A single acorn carried by the wind to a new patch of soil might one day change the shade of a valley, the flow of a stream, the fate of hundreds of animals. Small beginnings, immense consequences, the butterfly effect reborn in the forest. In ecology, this is sometimes called non-linearity, but we can understand it more gently as responsiveness. Nature is alive to its own changes. When one part shifts, everything else adjusts, sometimes gently, sometimes dramatically. It's a dance without choreography, guided only by the shared rhythm of adaptation. Consider the ocean, another vast breathing ecosystem. A bloom of microscopic algae appears, feeding on sunlight and nutrients. Fish come to feed on the algae. Larger fish arrive to feed on them. Seabirds follow. The algae vanish, the fish move on, and somewhere else in the world a similar bloom begins. The pattern is circular but never identical, because the conditions that shaped it are always changing. The same happens inside you. Your body, like the forest or the ocean, is a living ecosystem of feedback loops. Your cells respond to temperature, light, food, and emotion, adjusting thousands of processes every second to keep you balanced. The heartbeat, the breath, the release of hormones, all are guided by a quiet, dynamic chaos that makes life resilient. This, perhaps, is what makes chaos so comforting once you begin to see it clearly. It isn't randomness, it's responsiveness. It's life's way of staying alive. The forest doesn't collapse because of unpredictability. It thrives because of it. Its flexibility is its strength. The same is true for every system that grows and adapts. Imagine, for a moment, walking through that forest again, hearing the distant call of birds, the hush of branches brushing against each other. You notice the patterns, light shifting through leaves, insects tracing invisible paths, the rhythmic call of something unseen. It might seem chaotic, but if you listen long enough, the rhythm reveals itself, not fixed, but flowing, always adjusting to keep the balance between order and freedom. In science, we could describe this as dynamic equilibrium, but it might be easier to call it nature's patience. Life does not seek perfect control, it seeks balance, a kind of steady imperfection that allows it to endure storms, droughts, and change. And that balance isn't static, it moves like the waves of the ocean or the beating of your heart. The ecosystem never returns to exactly where it began, yet its harmony continues. This is how forests recover after fire, how coral reefs regrow after damage, how species evolve after catastrophe. Chaos is not the enemy of stability, it is the soil in which renewal grows. Perhaps the most humbling part of all this is realizing how deeply connected we are to these systems. Every breath you take began as a conversation between the trees and the air. Every drop of water in your body once fell as rain. Even your emotions follow rhythms not so different from the rise and fall of populations or tides, moments of growth, decline, recovery, and renewal. If you look at your own life this way, you might see that chaos has always been your quiet teacher. When things fall apart, new forms emerge. When patterns break, new possibilities appear. You are, in a sense, your own living ecosystem, adapting, responding, and finding balance again and again. So as the morning light filters through the mist of the forest in your imagination, you might feel a sense of peace in the unpredictability around you. Every rustle, every seed, every quiet breath is part of a vast, self-correcting story, one that began long before you and will continue long after. Chaos, in the end, is not the opposite of order. It is order that has learned how to move. Picture a crowded marketplace at sunrise. The air buzzes with quiet anticipation. Vendors arrange their fruits and spices, coins clink softly, and voices rise and fall in gentle waves. Each decision made here, a price agreed upon, a trade completed, a word spoken, may seem small, fleeting. Yet together they weave the vast and invisible fabric of the economy, a living system as unpredictable and sensitive as the weather or the forest. The stock market is often described in numbers and graphs, but beneath those symbols lies something deeply human. Every movement of price reflects the heartbeat of hope and fear, the push and pull of countless choices. A whisper of good news might lift spirits and prices together, while a rumour, even a faint one, can send entire markets tumbling. It's easy to think of these swings as chaos, but in truth, they are the same patterns of feedback and sensitivity that govern clouds, rivers, and living things. Imagine it this way. When investors buy more of something, its value rises. That rise attracts others who don't want to miss the opportunity, which makes the value climb faster. But eventually confidence grows too strong, and the system becomes unstable. A small spark, a change in mood, a moment of doubt, can start a cascade in the opposite direction. Prices fall, fear spreads, and the same feedback loop that once created growth now fuels decline. These cycles of optimism and fear, expansion and contraction, resemble the natural rhythms of predator and prey. When optimism is abundant, the market overgrows, consuming more than it can sustain. When fear returns, the system shrinks back, learning balance the hard way. Yet each rise and fall leaves behind new patterns, new adaptations, new awareness. The economist's charts may show jagged lines and sudden drops, but beneath them lies something poetic, a record of human emotion written in numbers. Each spike and dip is a story of collective mood, of trust, greed, caution, and recovery. The market, like the weather, doesn't follow a straight path. It drifts, loops, and occasionally storms. And just as a butterfly can stir the air into a cyclone, a single decision, a speech, a policy, a tweet can ripple through the entire system, reshaping economies on the other side of the world. It might be tempting to believe that with enough data, we could predict it all. But the economy, like nature, resists control. It's a chaotic system not because it's random, but because it's alive with interactions. Every buyer, every seller, every company, every dream is part of a feedback loop that constantly reshapes itself. To understand this more gently, imagine throwing a pebble into a still pond. Ripples spread outward, meeting other ripples, overlapping, colliding, amplifying, cancelling. The surface becomes a shifting mosaic of interference. That is what happens in societies and economies. Each decision, each pebble, interacts with countless others. Sometimes the ripples create harmony, sometimes they create turbulence, but always the movement continues. In mathematics, such systems are called nonlinear, meaning that effects don't always match causes. A small cause can have a huge effect, and a large effort can sometimes barely make a difference. In daily life, that truth feels familiar. One person's kindness can transform a day. One careless choice can spread harm farther than intended. Nonlinearity, in its quiet way, governs not just markets but human relationships. Even cultures evolve this way. Ideas move through societies like currents in the sea. They meet resistance, change direction, merge with others. Some fade quietly. Others grow into waves that reshape nations. Innovation, fashion, technology, even politics, all move through these unpredictable tides. A single invention or thought, born in one small corner of the world, can echo through generations, altering how people live, work, and dream. It is chaos, yes, but not disorder. It's the same creative chaos that drives ecosystems and galaxies. The economy, after all, is just another ecosystem, one built from human choices instead of trees and rivers. Its energy comes from trust and trade, from the exchange of value and emotion. Its predators are speculation and greed. Its prey are stability and complacency. And like all ecosystems, it learns to adapt. Think of how markets respond to shocks. A sudden crisis might send fear surging through society, collapsing systems we thought unbreakable. Yet slowly people find new ways to connect, trade, rebuild and grow. Out of apparent collapse, order re-emerges, not because someone planned it, but because humans, like nature, possess an innate ability to reorganize. You can see this principle in your own life too. Every community you've been part of, a family, a workplace, a circle of friends, follows the same quiet patterns. Trust grows and breaks, relationships expand and contract, balance shifts, and over time, the group finds a new form. The same feedback loops that drive economies also shape emotions and understanding. A kind gesture can ripple outward, altering the entire tone of a room. A single argument can echo for years, reshaping connections in ways that no one could have predicted. In the grander view, chaos in social systems isn't a flaw, it's a form of collective learning. Each disruption forces adaptation. Each unexpected outcome teaches resilience. Societies like forests and weather systems thrive when they are flexible, when they learn to bend instead of break. Perhaps this is why absolute predictability feels lifeless. A world without surprise would be a world without growth. We evolve because we make mistakes, respond to them, and discover new paths forward. The unpredictability of human systems isn't evidence of failure, it's proof of life. So when you hear about markets rising and falling, about nations shifting and economies transforming, remember the larger picture. What looks like chaos from close-up often reveals hidden structure from afar. Just as storms clear the sky and fires renew the soil, disruption in human systems often clears space for renewal. The economy, like the forest or the sky, isn't separate from us. It is us, magnified. Every ripple, every rise and fall begins with human emotion, human thought, human choice. We are both the cause and the effect, the wave and the shore. And in that realization, uncertainty becomes less frightening. It becomes the hum of life itself, the sound of a million stories colliding, diverging, and somehow finding rhythm together. The same rhythm you can feel softly now, in your own breath, the quiet pulse of a world always changing, yet always returning to balance. As evening falls and the noise of the day begins to fade, something remarkable happens inside you. Your brain, that quiet universe of thought, memory, and imagination, begins to shift into a different rhythm. Electrical patterns flutter and rearrange themselves like clouds catching the last light of dusk. Neurons fire in unpredictable bursts, signals ripple through hidden networks, and slowly you drift towards sleep. At first glance, this may seem like pure stillness, or ease, the mind resting after its long day of motion. But in truth, your sleeping brain is one of the most chaotic systems in nature. Beneath the calm of closed eyes, countless cells send electric whispers to one another in patterns that never quite repeat. Every dream, every flicker of imagination, every fleeting thought emerges from that soft turbulence. Scientists who study the sleeping brain once expected to find simple order, predictable waves, neat rhythms, patterns that could be charted like music on a page. And indeed, there are patterns. The slow waves of deep sleep, the quick flickers of REM, the transitions between them like phases of a gentle tide. But beneath these visible rhythms lies something deeper, the hidden chaos that gives rise to creativity, memory, and the mind's quiet resilience. In the waking state, the brain's activity resembles a river rushing over rocks, directed, purposeful, constrained by attention. But as you fall asleep, the current begins to wander. It splits, loops, and rejoins itself in unexpected ways. Regions of the brain that rarely communicate during the day begin to speak to one another in the dark, exchanging fragments of memory and emotion. This is where dreams are born, from the random collisions of thoughts and sensations that find new meaning in their meeting. Think of your brain as a vast orchestra. During the day, it performs a precise symphony, each section following the conductor's baton, each instrument keeping time. But at night, the conductor steps aside. The musicians begin to improvise. The violins drift into melodies from forgotten songs. The drums answer with echoes of heartbeat and rain. The horns call softly to distant memories, and somewhere in that improvisation, beauty emerges, fleeting, strange, and often profound. That's what chaos in the brain does. It breaks the rules just enough to find new ones. It explores the space between order and randomness, where creativity flourishes. In scientific terms, this space is sometimes called the edge of chaos, the place where systems are flexible enough to adapt but structured enough to stay alive. In human terms, it's where imagination lives. Every night as you dream, your mind rehearses possibilities it has never encountered. It tests stories, emotions, and patterns, reorganizing what you've seen and felt during the day into something entirely new. This is why a dream can sometimes reveal understanding before you consciously know it. The brain's chaotic dance is a form of learning, not through logic, but through play. Even when you wake, chaos remains your quiet companion. Every thought, every feeling, every creative spark arises from the unpredictable interactions of billions of neurons. No single cell knows what you're thinking, yet together they form a mind capable of art, laughter, love, and wonder. The brain's magic is not in its precision, but in its unpredictability. If you could somehow watch the activity of your neurons in real time, it would look like a shimmering storm of light. Each flash of electricity connects to thousands of others, forming webs that flicker and dissolve in milliseconds. Yet out of this restless movement emerges coherence, a sense of self, a stream of thought, a voice that says, "I am." Even consciousness itself may be an emergent property of this controlled chaos. Too much order and thought becomes rigid, repetitive. Too much randomness and thought dissolves into noise. Somewhere in between lies the balance, the same balance that shapes weather, ecosystems, and galaxies. The human mind is another fractal of the universe, a self-organizing pattern born from the delicate interplay of order and disorder. This dance extends beyond the brain alone. Inside you, a network of nerves stretches down into your body, communicating with the heart, the gut, and the immune system. Scientists now call this the gut-brain axis, a two-way conversation between your thoughts and your internal world. The tiny organisms living in your digestive system, billions of them, send signals that can influence your mood, your appetite, even your dreams. You are, in a sense, a collective intelligence, a living ecosystem in dialogue with itself. When this system is healthy, it behaves like a jazz ensemble, each part improvising within the same key, responding to the others with rhythm and grace. When it falls out of sync, the melody falters. But even then, chaos plays its role. The same unpredictability that creates imbalance also allows for healing and adaptation. The mind and body, through their endless feedback loops, learn new harmonies in the midst of noise. Think of the moments before sleep, when your thoughts start to wander, dissolving into fragments of memory and imagination. One image flows into another, a sound becomes a shape, a feeling turns into a story. This in-between state is where chaos and consciousness meet most tenderly. The mind lets go of control, allowing itself to drift into the unknown, trusting that something meaningful will arise. Dream researchers sometimes describe sleep as a nightly act of recalibration. Your brain reviews the day's experiences, discarding what isn't needed, strengthening what matters. But it does this not through strict logic, but through a process of exploration, trying, mixing, testing. The apparent nonsense of dreams is how the brain learns flexibility. The wandering mind is not lost, it is inventing. When you wake, your thoughts feel clearer, not because chaos has ended, but because it has done its work. Beneath the surface of your calm morning mind lies the same turbulence, always active, always ready to reorganize itself. The storm doesn't stop, it simply changes shape. So tonight, when you lie down and close your eyes, remember that what feels like silence is actually a symphony. Inside your head, tiny sparks of electricity will begin their nightly improvisation, creating new connections, dissolving old ones, building pathways of understanding that will shape tomorrow's thoughts. Your mind, even in sleep, is a living expression of the universe's favourite pattern. Order within chaos, chaos within order. Every dream you have, every flicker of thought, is another echo of the cosmos exploring itself through you. Rest then, knowing that you're in a world, as wild and unpredictable as it may seem, is part of the same harmony that moves the stars. The chaos within you is not something to be tamed, it is the pulse of life itself, beating softly beneath the veil of sleep. If the brain is an orchestra of lightning, the heart is its drum, steady, patient, and full of quiet surprises. You might think of your heartbeat as perfectly regular, a mechanical thump repeating every second or so. But if you listen closely, truly listen, you'll find that it's never quite the same twice. Each beat is a whisper different from the one before, a momentary variation, a subtle improvisation within the body's endless song. That small irregularity, that living flexibility, is what keeps you alive. A heart that beats with robotic precision is not a sign of health, it's a sign of fragility. Real hearts, healthy hearts, breathe with the world around them. They speed up when you laugh, slow down when you sigh, pause briefly in wonder, quicken in joy, and tremble in fear. Each emotion, each thought, each breath sends ripples through your pulse. This gentle variability is sometimes called heart rate variability, but it isn't a number to measure, it's a rhythm to feel. It's the body's way of staying adaptable, of adjusting in every moment to the world's endless changes. In a sense, your heart is a listener, constantly reading the signals sent by your nervous system, your lungs, your hormones, your mind. Every second, it performs a complex dance of feedback and response, a kind of internal conversation that never stops. Imagine a dancer performing with perfect grace. Each step follows the music, but not mechanically. There's intuition in it, a feeling for the space, the audience, the mood. Your heart dances like that. Its rhythm isn't imposed by force, but guided by flow. The signals that control it, electrical pulses, chemical cues, subtle nervous whispers, form an intricate web, all adjusting to one another in real time. If you could watch those signals unfold, it would look like the soft flickering of fireflies across a summer field. Each flash influences the next, creating waves of light that seem both random and perfectly synchronized. That's what your heartbeat is, order emerging from gentle chaos. There's an elegance in how it adapts. When you inhale, your heart quickens slightly, preparing the body to receive oxygen. When you exhale, it slows, allowing calm to return. This small rhythm, called respiratory sinus arrhythmia, scientists, though we might simply call it the breathing dance, links your lungs and your heart in a duet that keeps you balanced. Even the way your heart responds to emotion carries this same pattern of feedback. When you experience fear or excitement, your body releases signals that prepare you for motion, a relic of ancient survival. But when you find peace or safety, your body releases signals that soften the pulse, easing the rhythm back into calm. The system never stands still. It flows, constantly recalibrating, constantly learning. It might surprise you to know that the heart sends signals back to the brain too. For centuries, we imagined that command flowed in only one direction, from mind to body, from thought to muscle. But research has revealed something more poetic. The heart is not merely following orders, it's also speaking, influencing emotion, attention, and even perception. When the heart beats in a smooth, coherent rhythm, the brain's electrical activity harmonizes with it. Your mind becomes clearer, more stable, more at peace. When the heart is erratic, the mind can feel restless too. In that sense, emotion itself is a dialogue, a conversation between rhythm and thought. Your body and your mind are not separate, but two sides of the same wave. The Greek philosophers once said that harmony was the secret of health, and they were more right than they knew. You're an instrument tuned by the interplay of countless signals, neural, chemical, emotional, all weaving into a single melody. And like all melodies, this one changes with time. The young heart beats fast and irregular, full of energy and curiosity. The aging heart slows, finding steadiness in the rhythm of experience. But at every stage, the same principle holds true. Flexibility is life. The heart that listens, that adjusts, that moves gracefully with what comes, is the one that endures. Chaos, in the quiet language of biology, means sensitivity, the ability to respond to even the smallest shift. A perfectly predictable heartbeat would mean the system has stopped listening. But your heart listens always. When you rest, it hears your body sigh in relief. When you stand, it hears the call for more energy. When you feel love or sorrow, it hears the echoes of those emotions and translates them into motion. In that way, your heart is not just a pump, it is a poet, translating experience into rhythm. Each beat tells a story of where you are, what you feel, and what you hope for. It has been doing this since before you were born, before you took your first breath, beating softly in the darkness, guided only by the hidden mathematics of life. And though you cannot consciously control every beat, you can meet it halfway. When you breathe slowly, your heart follows. When you pause to calm your thoughts, the signals that guide your pulse soften too. The simple act of being aware of your heartbeat, of placing a hand on your chest and listening, can bring the system into harmony, as if the dancer heard the faint echo of the drum and smiled. In the language of science, this is called biofeedback, but in the language of experience, it's simply awareness. The recognition that you and your body are not separate observers, but partners in a shared dance. The calm you create in your thoughts ripples into your pulse. The steadiness of your breath becomes the steadiness of your heart. It's fascinating to think that this quiet, chaotic rhythm, beating roughly 100,000 times a day, is governed by laws not unlike those that shape the stars. Gravity holds galaxies together in spirals, just as pressure and flow hold your pulse in motion. Both systems depend on balance. Too much energy, and they collapse outward. Too little, and they fall inward. Life, like the cosmos, exists in that narrow space between, the edge where stability meets movement. So as you rest, maybe take a moment to feel that steady rhythm inside you. It's not a perfect metronome, nor should it be. Its beauty lies in its small irregularities, in its responsiveness. Each heartbeat is unique, yet part of the same endless pattern. A reminder that perfection isn't symmetry, but sensitivity. And if you listen long enough, you might hear in its rhythm the soft echo of the universe's own heartbeat, the quiet pulse that keeps everything alive, from the flutter of a leaf to the turning of galaxies. Imagine shrinking down, softly, until the world around you dissolves into patterns of light and motion. The air becomes a sea of shimmering particles, and every surface you see, your skin, your lungs, the space within your heart, is alive with movement. Cells divide, communicate, repair. Invisible rivers of chemistry flow through you, forming bridges between trillions of living pieces. Each one knows its role, though no single cell is in charge. You are not one being, but an entire universe of tiny lives connected in a web of exquisite chaos. Inside your body, more organisms live than there are stars in the Milky Way. They are so small you cannot see them, yet together they outnumber your own cells. They dwell in the dark corridors of your intestines, in the folds of your skin, in the warm chambers of your lungs. Some are bacteria, some are fungi, some are so simple they blur the boundary between living and not. And though they have their own lives, they are part of yours too. You are their landscape, their weather, their world. Scientists call this community the microbiome, but that word barely hints at its wonder. It's not just a collection of microbes, it's an ecosystem, a living rainforest inside you, dense with exchange and cooperation. Every breath you take, every meal you eat, every emotion you feel ripples through this inner wilderness. When you change, it changes too. Think of a meadow after rain. The soil stirs, hidden seeds awaken, and life begins to hum beneath the surface. Some plants bloom quickly, others take their time. Some draw nutrients from the air, others borrow from their neighbours. Together they form a balance. Delicate, dynamic, never fixed. Your microbiome works in much the same way. It grows, competes, shares, and transforms in response to everything you do. The foods you eat, the sleep you take, the stress you feel. In this invisible world, chaos is not disorder, it is diversity. The more varied your inner ecosystem, the more resilient you are. Like a forest with many species, a diverse microbiome can adapt to change, healing when damaged, recovering when disrupted. Too little diversity, and the system grows brittle, unable to respond to the unpredictable rhythm of life. Within this living network, information travels constantly. Microbes send chemical messages that your body can understand, signals that can influence your mood, your appetite, even your immune system. Some produce molecules that help your brain make serotonin, the chemical that steadies emotion. Others help train your immune cells, teaching them when to defend and when to rest. Your health, in a very real sense, depends on the wisdom of these tiny neighbours. It may sound strange to think that your feelings could be shaped by microorganisms, but this exchange has always existed. When you eat a nourishing meal, when you breathe deeply, when you walk in nature and feel calm, your body sends signals of safety that ripple down to this microscopic world. The microbes respond in kind, producing compounds that nurture your cells and soothe your mind. The feedback never stops. It's a conversation that began before you were born and will continue as long as you live. Sometimes this conversation falters. A sudden illness, a poor diet, too little rest, or too much stress can shift the balance of species within you. Some microbes thrive in chaos, while others retreat. The result can feel like confusion, fatigue, anxiety, inflammation. But even in those moments, your body listens. It adjusts, recalibrates, and begins to rebuild balance, just as a forest regrows after fire. Chaos gives way in time to renewal. The same principles govern the immune system. Imagine an army that is both vigilant and wise, one that knows when to fight and when to stand down. The cells of your immune system, like the animals of a forest, communicate through chemical signals. They swarm, retreat, and reorganize with astonishing speed. Their dance follows rules of sensitivity rather than rigidity. A single cell detecting a threat can call others to respond, setting off a cascade of action. Yet, if the system overreacts, it can harm the very body it protects. Balance again lies at the edge of chaos. Order flexible enough to learn, chaos calm enough to heal. If we could translate the language of these cells, it would sound like a symphony played in whispers. Molecules drift like notes between them, some urging growth, others calling for calm. The melody changes with every moment of your life. When you feel joy, when you rest, when you walk in sunlight, the rhythm smooths. When you feel fear or exhaustion, the melody grows restless. Your body's internal ecosystems are always responding, always composing new harmonies. The beauty of chaos inside you is that it allows for creativity. In the process of adaptation, new possibilities appear. A cell that mutates slightly might one day help you heal faster. A microbe that learns to break down a new kind of food might make your digestion stronger. Life experiments constantly, and most of those experiments fade quietly away. But some succeed, and through them, evolution continues. The chaos inside you is the seedbed of your own becoming. Even consciousness, the feeling of being you, depends on these countless living systems working together. Your mind does not float above your body, it arises from it. The same chemical signals that help microbes communicate help neurons communicate too. It's as though your body and your microbiome are one vast neural network, exchanging stories through chemistry instead of words. When you take a deep breath, you're feeding this network oxygen and calm. When you eat a piece of fruit, you're feeding both yourself and your inner forest. When you laugh, the vibration of your diaphragm massages your organs and moves the fluids that carry nutrients to your cells. Every action you take is a message to the living universe within. So perhaps the next time you feel small, remember this. You're a cosmos of your own. Within you, entire worlds rise and fall, thrive and transform. The laws that shape hurricanes and galaxies also shape your immune responses, your digestion, your very mood. The same chaos that stirs the clouds also stirs your blood, and yet, somehow, all of it holds together. Your body, this shimmering constellation of atoms and organisms, hums with coordination so complex that no supercomputer could reproduce it. You're not chaos struggling toward order. You're order born from chaos, constantly renewing itself with every breath. If you listen closely, in the quiet between heartbeats, you might almost hear it. The faint, endless music of the living systems within you, improvising in real time, keeping you alive in a harmony that no composer could ever write. Somewhere between order and disorder, between stillness and movement, the world becomes most alive. You can see it in the flicker of a candle's flame, never holding the same shape yet never losing its light. You can hear it in the rustle of leaves, not silence, not noise, but something in between, full of rhythm and unpredictability. This delicate balance is what scientists call the edge of chaos, the mysterious frontier where systems are neither frozen nor falling apart, but dancing on the boundary between the two. To understand it gently, imagine a line drawn in sand, separating calm water from breaking waves. On one side, everything is still, no motion, no change. On the other side, the surf is too wild to sustain shape or pattern. But right at that border, where the waves rise and collapse, where foam forms and vanishes, new shapes are constantly being born. Shells wash up, bubbles form, sand shifts and sparkles. It's a place of constant creation. Every living system, from your heartbeat to the weather to the flow of galaxies, exists near that edge. Too much order, and it becomes brittle, unable to grow, unable to respond. Too much chaos, and it dissolves into noise. Life thrives in the narrow space between, where stability meets spontaneity. That's where adaptation happens, where creativity emerges, where the world learns to renew itself. Picture a pile of sand, grain by grain, forming a small cone on the table. For a while, each grain you add settles harmlessly into place. The pile grows taller, stable, and quiet. But eventually one single grain, no different from the rest, will cause an avalanche. The entire slope shifts, rebalances, finds a new shape. No one could predict exactly which grain would do it, or when. That's the essence of the edge of chaos. Systems that remain poised for change, waiting for the right moment to transform. It isn't just sand. Forests too live on that edge. Each tree competes for light and water, but together they form a web of stability. A drought, a fire, a fallen tree. These disturbances may seem destructive, yet they open space for new life. The forest's resilience comes from this interplay between destruction and renewal. Chaos creates the conditions for rebirth. Your own mind works in the same way. Creativity doesn't bloom in complete order, where everything is predictable, nor in total confusion, where nothing makes sense. It emerges in the middle ground, when ideas jostle, connect, and collide, forming new patterns that surprise even you. The artist standing before a blank canvas feels both fear and possibility. The scientist at the edge of a new theory faces the same threshold. Order dissolving into uncertainty, then reforming as insight. If life were perfectly orderly, it would be lifeless. Nothing new could happen. But if it were completely chaotic, nothing could endure. So nature has chosen the edge, a kind of eternal balancing act. The very fact that you exist, that you can think and change, means your body, your mind, and your world are all operating in this zone of dynamic tension. Even evolution follows this rhythm. Species that are too rigid in their habits vanish when the environment changes. Those that are too chaotic fail to survive long enough to reproduce. The winners are those balanced between, stable enough to persist, flexible enough to evolve. The same applies to human societies. Cultures that refuse change become brittle. Those that chase every new impulse lose their coherence. But at the edge, where, Tradition meets innovation, civilization grows. In science, some describe this balance using the language of networks and feedback, but we can understand it more simply as responsiveness. A healthy system listens to itself. It allows movement without collapse, structure without suffocation. It's the same principle that guides your immune system when it responds to an infection, quick to react, yet able to calm itself afterward. Think again of that sand pile. Each grain that falls represents a moment in time, a new experience, a new idea, a new possibility. Most settle quietly, but sometimes one changes everything. In your own life, this happens too. A single conversation, a sudden realization, a chance encounter. These are the grains that send the slope shifting. They trigger the avalanche that rearranges your world, revealing a new shape you couldn't have predicted. And just as in the sand pile, this transformation isn't destruction, it's renewal. The system doesn't fall apart, it reorganizes. The old pattern makes way for something more stable, more intricate, more alive. Chaos, when met with awareness, becomes evolution. You can even feel the edge of chaos within yourself, in those moments of decision when the familiar begins to fade and the unknown approaches. Your thoughts race, your heartbeat quickens, yet part of you stays still, waiting. This tension between fear and curiosity, between what was and what could be, is the same dynamic that shapes galaxies and living cells alike. It is the creative tension of existence. The poet Rainer Maria Rilke once wrote, "Let everything happen to you, beauty and terror. Just keep going. No feeling is final." That line captures the spirit of the edge of chaos. It's not about avoiding instability, but embracing it as part of growth. The universe itself has been balancing on this edge since the beginning, expanding, cooling, collapsing, forming stars and repeating the cycle. Each fluctuation, each catastrophe, gives rise to new patterns, new forms of order. So perhaps the real art of living lies not in seeking perfect control, but in learning to move gracefully within unpredictability. To be like a tightrope walker, balancing between stability and discovery. To trust that even when the ground shifts beneath you, you're part of a larger pattern that knows how to find its own rhythm again. Every time you adapt, every time you learn, you are dancing on that same invisible line. It's where chaos turns into creativity and where uncertainty becomes possibility. The edge of chaos is not a place to fear. It's where life truly happens. So if you ever feel yourself standing at that edge, unsure, unsteady, perhaps a little afraid, remember that you're in good company. Every heartbeat, every forest, every cloud, every star lives there too. It is the universe's favourite place, the boundary between what has been and what might be. And from that boundary, all creation begins anew. Imagine holding a single grain of dust in the palm of your hand. It looks still, harmless, ordinary. Yet deep inside that grain, countless tiny particles, atoms, electrons, quarks, are dancing. They don't move in neat, predictable lines, but in clouds of possibility. Each moment they shimmer between what they are and what they might become. It's strange to think about. The smallest building blocks of the universe don't obey the tidy rules we expect. They live in a world of uncertainty, a world that doesn't show us where something is and how it's moving at the same time. This is the realm of quantum physics, the world beneath the world, where nature hums in probabilities instead of certainties. You can picture it as a soft fog surrounding every particle, a blur of potential paths, each one waiting to be chosen. Only when you look closely, when you try to measure or observe, does the fog collapse into a single outcome. Until then, it's not that the particle is hidden, it's that it's everywhere it could possibly be, all at once. A physicist named Werner Heisenberg described this in what we now call the uncertainty principle. He found that the more precisely you know where something is, the less precisely you can know how fast it's moving, and vice versa. The two pieces of information exist like a seesaw. Balance one side, and the other rises beyond your reach. But rather than seeing this as a flaw in our tools, Heisenberg realized it was a truth about reality itself. The universe, at its most fundamental level, is not a clock, it's a wave. If that sounds abstract, imagine trying to describe the ocean by catching a single drop of water. You could measure that drop perfectly, its weight, its temperature, its clarity. But in doing so, you lose the sense of the wave it came from. The motion, the energy, the rhythm are gone. The act of isolating the droplet breaks the very pattern that makes it meaningful. Quantum mechanics is much the same. The moment we observe the tiniest parts of nature, we freeze them in place, and the dance disappears. For centuries, science built its strength on predictability. If you knew where a planet was and how fast it was moving, you could calculate where it would be tomorrow, next year, even 1,000 years from now. The laws of motion were elegant and precise. They promised a world that could be known completely, if only we had enough information. But quantum uncertainty quietly changed that story. It showed that even with perfect knowledge of the present, the future might not be fully determined. There is always a whisper of indeterminacy, a shimmer of possibility that cannot be erased. It's tempting to think of this uncertainty as chaos, but it isn't quite that. Chaos is sensitivity, small causes leading to large effects. Quantum uncertainty is different. It's not that we can't predict because we don't have enough data. It's that nature itself doesn't decide until the moment it must. The universe, in this sense, is improvising. And strangely, this improvisation may be the reason anything exists at all. In the beginning, just after the Big Bang, energy and matter were perfectly balanced. Particles and antiparticles paired off like reflections. By the simplest logic, they should have annihilated each other, leaving behind only light. But somewhere in that dance of probabilities, the balance tilted by the smallest imaginable margin, and a tiny excess of matter remained. You, me, every star and planet are made of that sliver of asymmetry. Without the universe's uncertainty, there would have been nothing solid to stand on. You can think of it like the roll of a cosmic die, not one of chance, but of potential. Out of infinite possibilities, this one reality came into being, and the same process continues every moment on every scale. Each electron deciding where to exist, each atom bonding with another, each neuron in your brain firing or remaining still, all guided by probabilities, all creating new outcomes that could never be perfectly predicted. Even your thoughts arise from this sea of uncertainty. A single neuron fires a fraction of a second earlier or later, and your mind takes a different path, a new idea, a forgotten word, a sudden memory. The butterfly effect lives here too, but in miniature, a universe of small beginnings within the universe itself. In this light, uncertainty isn't something to fear, it's what gives the world texture. It's what allows freedom and creativity to exist. A universe without it would be static, frozen in its first breath, repeating itself endlessly. But a universe with it can evolve, explore and create. Every act of change, from the flicker of a candle to the birth of a galaxy, is a story written by uncertainty. To feel this idea more gently, imagine standing at the edge of a pond just after sunset. You throw a pebble into the water. The ripples spread outward, touching everything. But the air shifts slightly, the light fades, a leaf falls nearby, and suddenly no two ripples are ever the same. You could never predict exactly how the pattern will form, yet in its unpredictability lies its beauty. Each wave is unique, unrepeatable, alive. That's what the quantum world is like. Not random, but full of possibilities, each one shaped by the smallest, quietest influences. It's chaos refined into poetry, uncertainty transformed into existence. Even at cosmic scales, this principle still whispers. Stars form because particles move unpredictably, clumping just enough to ignite. Galaxies evolve because gravity tugs unevenly across the void. The same delicate tension between predictability and freedom runs through everything, from the quiver of an electron to the swirl of the Milky Way. And perhaps it runs through you too. Your thoughts, choices and emotions are not pre-written equations. They're waves collapsing into reality each moment, shaped by memory, by feeling, by chance. When you decide, when you create, when you change, you're echoing the same principle that built the universe, uncertainty made visible. The physicist Niels Bohr once said, "Anyone who is not shocked by quantum mechanics has not understood it." But maybe shocked isn't quite the right word. Maybe humbled fits better. Because what quantum physics reveals is not chaos for its own sake, but a kind of cosmic generosity, a willingness of the universe to allow surprises. So when you face uncertainty in your own life, you might remember that it's not separate from the fabric of existence. It is the fabric. Every unknown future, every unanswered question, every open possibility is the universe doing what it has always done, exploring its own potential, one moment at a time. The same way an electron chooses its place in the fog, you too find your position in the world, not through perfect knowledge, but through gentle motion, step by step, breath by breath, choice by choice. And in those choices, unpredictable yet meaningful, the story of reality continues to unfold. And so, we've travelled from the flutter of a butterfly's wings to the trembling of subatomic particles, from the wild pulse of storms to the quiet rhythm of the heart. Along the way, we've seen that chaos is not disorder, not madness, not a flaw in the grand design. It's the language of the universe itself, a soft-spoken dialect of balance, surprise, and connection. Chaos theory, at its core, is a love story between predictability and possibility. It tells us that the world is not a machine grinding toward an inevitable future, but a living, breathing web of relationships. Every heartbeat, every gust of wind, every flicker of thought is linked to something else, somewhere, in ways we may never fully understand. It is both humbling and comforting, the knowledge that even the smallest act, the smallest whisper, contributes to the unfolding shape of existence. The lesson of chaos is not that we live in confusion, but that we live in conversation. The universe does not move in a straight line. It spirals, loops, and folds back on itself like waves crossing the sea. It repeats without repeating, finding new forms within familiar rhythms. This is why no snowflake, no tree, no life is ever quite the same. The formula may be constant, but the outcomes are infinite. Think of a single drop of rain falling through the atmosphere. Its path is determined by gravity, air pressure, temperature, and chance encounters with dust or wind. Every drop follows the same laws of motion, yet no two fall the same way. They weave through invisible corridors of turbulence, tracing paths that could never be mapped twice. And yet, all of them arrive, quietly, gracefully, at the earth. Life unfolds much like those raindrops. We follow the laws of biology and circumstance, yet each of us drifts through unique currents of choice, chance, and change. No life can be predicted, and none are wasted. Chaos ensures that even when the patterns seem broken, meaning still hides beneath the surface, waiting for time and perspective to reveal it. If you look back on your own life, you might notice moments that felt random at the time, a conversation overheard, a journey delayed, a chance meeting. Each seemed small, almost forgettable. But somehow, those small things shaped who you became. Chaos has always been your silent sculptor. It works not in straight lines, but in spirals, revisiting the same themes until they make sense. The mistakes you made, the detours you took, the people you met, all are part of a pattern that could never have existed without those tiny imperfections. This is perhaps the most beautiful truth chaos theory offers, that imperfection is not failure. It is the space where growth happens. If the universe were perfect, if it followed its equations with rigid precision, there would be no novelty, no evolution, no love, no you. It's the unpredictability of the world that allows life to bloom. Even in the vastness of the cosmos, the same lesson holds. Stars are born from chaos, from swirling clouds of gas collapsing under their own weight, from temperature differences and turbulence, from the delicate imbalance between gravity pulling in and radiation pushing out. The universe's order emerges not in spite of chaos, but because of it. Every sunrise, every galaxy, every heartbeat is a quiet echo of that first cosmic improvisation. And so, chaos becomes a teacher, not of control, but of humility. It reminds us that we cannot predict everything, and that's a mercy. Imagine if we could, if every outcome, every encounter, every future were known in advance. The mystery would vanish, and with it, wonder. The unknowable is what gives life its depth. The edge of uncertainty is where meaning takes shape. Scientists, philosophers, and dreamers all come to the same realization in their own ways, that knowledge has limits, but awareness has no end. The goal of understanding chaos is not to tame it, but to listen to it, to feel its rhythm in the pulse of our own lives. The universe does not demand certainty from us. It asks only curiosity. When you look at the night sky, you're seeing the afterglow of ancient chaos, light that has travelled across unimaginable distances and times, shaped by collisions, gravity, and decay. And yet, what reaches your eyes is harmony. The stars arranged in constellations, the planets following their graceful arcs. Beneath every pattern you see lies 1,000 small uncertainties, balanced perfectly on the edge between order and possibility. If there's a lesson in that, it may be this. Life's beauty doesn't come from control, but from participation. You don't need to understand every variable or anticipate every outcome. You only need to step into the flow to let yourself be part of the pattern, shaping and being shaped in return. When you act with kindness, when you create something, when you love, you set ripples into motion that will travel farther than you can imagine. You may never see where they go or what they change, but the mathematics of chaos assures us nothing is lost. Every movement becomes part of the whole. Perhaps that's why small acts matter so much. A smile, a word, a moment of patience. Each one alters the invisible geometry of another life. Like the butterfly's wings, they travel quietly through the air of human connection, shifting futures we may never know. So tonight, as you rest, you might think of yourself as part of this vast breathing system, a single point in the ever-changing fabric of time. You're not separate from the patterns you see. The same rules that guide galaxies guide your heartbeat. The same unpredictability that shapes storms gives rise to your thoughts. You are, in every sense, a child of chaos, and through that chaos, of beauty. If you could zoom out far enough, beyond your city, beyond the clouds, beyond the stars, and look back at yourself from the edge of the universe, you would see not confusion, but coherence. You would see the delicate threads of cause and effect, looping and shimmering like light through water, all woven into the same tapestry. Every life, every moment, every small beginning connected in one great pattern that never repeats yet never ends. And that pattern, in all its vastness, would look strangely familiar, like the branching of rivers, the spiraling of galaxies, or the quiet fractal of veins across your hand. The same shape, the same song, echoing through scale after scale, from the microscopic to the infinite. Chaos doesn't destroy meaning. It deepens it. It reminds us that the unknown is not emptiness. its possibility, that the future isn't written in stone, but whispered softly in every decision, every kindness, every dream. And as you drift towards sleep, you might feel a quiet comfort in knowing this. The universe doesn't need to be certain to be whole. You don't need to understand every step to be exactly where you belong. In the gentle balance between order and mystery, between knowing and wondering, the cosmos keeps its most peaceful truth, that even in apparent disorder there is beauty, and in every beginning there is hope.